Propose the structural formula for compound B with molecular formula C6H13NO consistent with its H&MR spectrum and IR spectrum. Now, since the molecular formula has been given, our first step here would be to find the degree of unsaturation. So let's find the degree of unsaturation here using the formula 2C plus 2 plus nitrogen minus hydrogen minus X divided by 2. So the degree of unsaturation here has been found to be 1. So we can assume that it could be a ring structure or it could be a double bond. Now let's take a look into the IR spectrum to find the important functional groups existing in this molecule. Now since it has got nitrogen, we wanted to see whether there is going to be any amine groups or amides or nitriles present in the compound. So we can see here around 3300 there are 2 peaks, and this could be easily correspond to the NH stretching vibrations in the NH2 group. Okay, so this is going to be the NH stretching vibrations for the 2 NH bonds that's present in the primary amine, right? And then here we can see, let's see if we can drop the line here. So we only have peaks that's coming on the right side of 3000. So this could be easily corresponding to sp3 carbon hydrogen stretches. Okay, and around 1680 we have a peak, sharp peak, that's going to correspond to carbon oxygen double bond, the carbonyl group. And then here around 1580 going to correspond to the NH bending vibrations. Okay, so now these are the information. So from here we could clearly see that there is a carbonyl group, right? And then there is also an NH2 group. These are the two functional groups that are present in the molecule. Okay, now let's try to subtract these two things from our molecular formula to find out the rest of the pieces. So from our original molecular formula, which is C6H13NO, we are going to subtract these two stuff. That's going to give us C5H11. Because we have 2 hydrogens that we needed to subtract from 13, so that's going to be H11. And 1 oxygen and 1 oxygen has got cancelled, and you have 1 nitrogen and 1 nitrogen that should get cancelled. So this should be the rest of the molecule. Now let's go to the H&MR spectrum to find how the C5H11 is existing in the molecule. Okay, so here we have 3 hydrogens. So this 3 hydrogen is going to correspond for a methyl group. And when we look into the splitting pattern, we can see that this is a triplet, which means it is adjacent to a methylene group. So let's do this. So we're going to say this as CH2, CH3, and it is this CH3 which is going to correspond to this peak. Okay, and now when we go on to the left side, we can see there are 4 hydrogens. We can see these 4 hydrogens are going to be corresponding to 2 methylene groups, which are going to be pretty much in the same environment. So we can consider this as CH2, CH2, right? And here we can see there's also a peak that is corresponding to 2 hydrogens, and let's consider the multiplicity of it. 1, 2, 3, 4, 5. It is split as a quintet, which means it should have a total of 4 neighboring hydrogens. So only way that it's going to have 4 neighboring hydrogens is if it is adjacent to 2 methylene groups, right? So this CH2 is going to correspond for that. And now let's go on to the next one. So here we see a triplet. So which means these protons are also adjacent to a CH2 group, right? Which also should be corresponding to methylene groups, which also should correspond to a methylene group. So we need to see a total of 11 hydrogens. So here when we count the number of hydrogens here, 3 plus 2, 5, 5 plus 2, 7, 7 plus 4, that would be 11. We can say that all of these groups are arranged in a row. Okay, so let's put that together. So this is going to be CH3, CH2, 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 and CH2. And we also see 2 peaks here, 2 signals here. This is going to correspond for the NH peaks. And then NH peaks are normally broad, and they can fluctuate. Okay, now when we put all of these things together, so we can see that this is going to be one piece, and this is going to be another piece, and this is going to be the other piece. So when you put all of these three things together, the only way that they can be arranged is when it's going to be an amide. So the structure here is going to be hexanamide. Okay. The structure of this compound is going to be hexanamide.